I'm going to go over bubble sort in Clojure. Bubble sort's one of the most simple sorting algorithms out there. You usually learn it in your data structures class that you take either freshman or sophomore year of undergrad, but the bubble sort tutorials I saw for Clojure didn't really, I feel, explain how to think about it recursively too well, at least to me. So if I was trying to learn Clojure, I'd appreciate a video like this, so I thought I'd just make a quick demo. And maybe Clojure is much harder than Scheme because I had a lot more trouble using Clojure than Scheme, and I think it's just the vector versus list difference. So most of the time, you do bubble sort iteratively. You think about the imperative structure of most programming languages. That's not functional. So in Clojure, you have to do it recursively. So the first step of any recursive problem is what's the base case, and luckily for us, we know that there's a base case when the bubble happens and there's no change to the list. So in this example down here, we have the first list. You can see 2 needs to be swapped up, bubbled up. And once that happens, if we look at the list before and after and we don't see a change, that's the base case. We know we've hit it. We've fully sorted the list. So to start, one of the unique things about Clojure that's really nice is it has a destructuring. So here we'll break whatever list gets passed in or vector into a head tail, or the head of the tail, and then the tail, which is everything that's left. So the only thing we need to do is we have to decide how to combine these 3 elements based on whether or not the head is bigger than the head tail, in which case we'd have to swap it. So if I go here, we can see it destructures everything perfectly. We get 1 for the head, 2 for the tail, and then the rest of the list for the tail, or 2 for the head tail, sorry. So putting it together, we'll have this recursive function that kind of bubbles up the entire list. So this would be like 1 iteration if we were doing this imperatively. So this is basically I through n. So this would have an n runtime as it bubbles from the head, the original head of the list, all the way to the very last element in that list. So here we'll check for the end of the list to make sure that we have 2 elements to swap. And then if we need to swap, we swap and then recur on the tail, or we just recur. And here what we're doing is we're consing this tail head to head in the recursive call. But if we don't need to swap, we just bubble the rest of the list. And I could have used cons tail head and then bubbled on tail, but we can just use rest on list, and that gives us tail head and tail in one. So let me run this. So now we've got that function bubble. And now the final method is just to kind of lump everything together, and we'll recursively check for that base case, which is if list is equal to bubbled, and here bubbled is just the process list. So one of the nice things about Clojure and most Scheme Lispy languages is we have the let function, or macro, I'm not sure, I think just a function. And here we can define bubbled and then call the bubble function on the list. And we check and we recur. And one thing you might notice is that in this we can use recur, whereas here we can't use recur. And the reason for that is because recur has to be the last call of the function. So if recur was here or here, then we could do it and we'd have tail call optimization, essentially a Clojure version of that, which would speed things up a little bit and kind of prevent the stack from exploding. But unfortunately, the way that I've implemented it with my knowledge of Clojure, I can't make that happen. Now let's test it out. So we've got a random list with some random numbers, and we'll see if it works on that, if it works on an empty list, and then if it works on a list with 1 element. You want to try first, middle, end, and many usually when you're testing. So let's go here. There we go, perfect. So we've got that desired result. And then just a quick test, I'll go here and look at a real, quote-unquote, real-life example. So I just generated 1,000 random ints, which you can see here. And I use Clojure to slurp those in, trim it, split it, create a vector, and then map read string across that vector to get numbers, and then do the exact same function across it. So if I go here, we can see that I have working pretty quickly. If I hyperfine it, it's also pretty speedy. Yeah, about 600 milliseconds, which is pretty good. The unoptimized Rust bubble sort that does the same thing with the same file is about 200. But one of the great things about Rust is that when you run Rust C with the O tag, just because I'm not doing it as a project, you really optimize that binary. So you'll see if I do this, it's pretty much instant, which is nice. Let's see here. No, this isn't a Rust video, so feel free to end, but you can see almost 2 milliseconds, crazy speed increase, and I'm sure that I'm probably making some errors or some unoptimizations. You know, there's some room for optimization here, probably with these recursive calls, but still I'd say 600 milliseconds for that isn't terrible, and allowing yourself to think recursively about things can only make you a better programmer, and I'd say that's what I'm using Clojure for. I don't see myself using it professionally, maybe for some small side projects, but I think that thinking about things recursively instead of iteratively, kind of getting a sense for a functional language where it really forces you to be functional, can only increase your skill as a programmer, as a developer. So that's what I hope to get out of it. Hope that this video helps. Let me know in the comments.